So chapter 13, we're going to take a look at financial mathematics in this chapter, and we're going to start section 13.1 with the time value of money. Most of what we do, or at least a good portion of what we do in 13.1, is going to feel like something you've seen before, even if you don't quite remember how it worked when you saw it before. It's going to feel familiar, okay? So our leading idea is the following. The time value of money teaches us that value changes over time. How investing wisely today can lead to greater rewards in the future. Similarly, faith in God encourages patience and trust in a larger plan, believing that the choices and commitments we make now can yield lasting, meaningful results. Just as understanding time's impact on money helps us make better decisions, God invites us to consider how our present actions shape the future in profound ways. And let's pray. Dear Heavenly Father, I thank you for an opportunity in this class specifically to finish up with something super practical, something that we're all going to be working with both now and in the future. And I just pray that as we work through this material, that there would be pieces of this especially that would resonate and that we would remember when these events come up later in life, that we've seen how this works and that we can make wise choices that honor you. Help our time together today to be productive. We pray in Jesus' name. Amen. Okay. Our first type of time value of money we're going to look at is going to involve what's called simple interest. All right, so simple interest formula is I equal PRT, and each of those letters is defined as follows. I is the interest amount, and that's referencing a dollar amount. P, the principal, is also an amount. It's an amount of a loan if we're borrowing money, or an investment if we're depositing and trying to grow money. R is our interest rate as a decimal. For example, let's say we have 5%. Then our decimal would be understood to be after the 5. We would turn this percent into a decimal or its decimal form, and its decimal form would be 0.05. So every time we're looking at putting in a value for R, we need to change it from its percent form into its decimal form. And then time is always going to be measured in years. Sometimes they just tell you the number of years, but sometimes they might tell you a number of months. For example, if they said 18 months, you would have to turn it into the corresponding number of years, which would be 1.5 years. Okay? The most common errors that people make when they get calculations that are not correct, sometimes even completely unreasonable, is they either forget to change the interest rate into its decimal form, or they might forget to change a number of months into a number of years. Those are the two common ones. Okay? Now, looking at how much money we would have in the future is called the future value for the simple interest. There's two formulas, but they're really the same formula, just presented differently. The first one is A equals P times 1 plus RT. And if you were to distribute the P through, you'd have the second formula, which is A equals P plus PRT. The A here is the future amount. Okay, A for amount, that works. And you'll take a look, this amount then is taking the principal and adding to it the interest. So if we're having an investment, it's the amount that we put into the bank plus the amount that the bank gives us because we leave our money there. If you're talking about a loan, it's the amount you borrowed plus the amount of interest you paid for the luxury of borrowing somebody else's money. Okay, that's how much you would total owe back in the end. Okay, this shouldn't be brand new. Okay, this typically shows up in an Algebra 1 curriculum for the very first time. It re-shows up a lot of times after that, but that's where it's typically introduced. So I hope this at least looks somewhat familiar, even if you're looking at it now and go, yeah, but I don't really remember it. That's okay. It should still be somewhat, I've seen this before kind of a feel. I hope so. So let's take a look at an example of how this works. Recognizing right off the top that the context of this particular problem, I didn't create it on my own. It's not authentic because it's not really the way the IRS works, okay? But the calculation purposes and so forth, it's okay. So Paul is owed $530 by the IRS for overpayment of last year's taxes. In this scenario, not in real life, but in this scenario, the IRS will repay the amount at 4% simple interest. Okie dokie so far. All right. It says find the amount of interest, keyword is interest, that the IRS owes Paul. So looking at these two formulas, three formulas, I guess, which formula are we using for this question?
R equals PRT.
Okay, it is the I equal PRT because it says interest. It's asking us for the interest. Okay, is that okay for everybody? Okay, so our formula we're going to use is I equal PRT. Okay, the P is the amount that he overpaid, that he put, that he is owed back. So that's our 530. R. What is the R value we're going to put in on this one? Yeah, 4%, which would be 0.04. I have to read through between the lines just a little bit on time. What is the T value, the time in this problem?
12 months or a year.
A year, yeah. So it says last year's taxes, so it would be 1 year. We'd put in a 1 for that. Okay, so for those of you who've trickled in since I made an announcement, if you don't have a calculator with you, come grab one. For everyone then, I'd like for you to enter this into the calculator. Obviously, you don't really have to enter times 1. That doesn't change the value on your values in this one. But we need to know what is 530 times 0.04. Yep. $21.20. And please pay careful attention inside of my math lab for how it wants you to round things. A lot of the time you're going to round it like this, right? It's numbers of dollars and cents. We have 2 decimals and all that's good. But sometimes it'll say to the nearest dollar. Okay? Obviously, if you made a mistake doing that on a quiz or a test, I'm going to edit it. Partial credit, it's going to be fine. But for a homework, it's just going to tell you the answer's wrong. So, be able to fix it that way. All right. Part B wants to know the total amount that the IRS owes Paul.
550 from 20.
Yes. So I'm going to let you tell me how you did it, Ashlyn, and then I'm going to show you the other option because there's going to be 2 ways to do it. How did you come up with that number?
That he overpaid them with the amount of interest that they owe back and added it.
Okay. So Ashlyn said there's an amount that the IRS owed him to begin with. That's the $530. And then there's the amount that the interest that they owe back now too, which is $21.20. And when I add them together, I get $551.20, and that's how much the IRS owes Paul. Okay, does that make sense? So this is kind of a friendly way to do it because we did part A already. Agreed? Yeah, I mean, so that's a very nice way to do it. If we were starting with part B and we hadn't have had a part A, we might actually want to go back to one of these formulas. Does that make sense? Now, we kind of used this formula already because we added the principal and the interest. True? Mm-hmm. So I'm going to suggest, just for the sake of seeing it done differently, let's show what it would look like if I used the top one. Okay? So another way to do this will be to take the P times 1 plus RT. So P's our principal, our 530. 1 plus my rate is 0.04 times the time is 1, like so. I would like for you to practice with your calculator putting that in. Okay. So if you do not have a real calculator, I need you to get a real calculator because your phone is not going to do things very well when we move into the next section. So come grab one, please, if you don't have one, so that when we get to the test, you'll know how to use the features to do that. The calculator, your phone works pretty okay for this first part on simple interest. It doesn't work so very good on the next part. Okay, so if we do it right, we should still get the same answer. Did you get the same answer?
Yeah.
Okay, Mandy says yes. Ashlyn says yes. I got 2 answers of yes. Please, please stop me if your calculator doesn't give you an answer so that I can look and see what your calculator did, or maybe a data entry that you did so we can fix it.
What mode is it supposed to be on?
It shouldn't matter. It'll look a little bit different on which mode you choose, but the mode should still work either way.
Cool. Because I got a different answer.
Okay, let me look at it.
Oh, I did 0.4. My fault. Awesome, thank you.
No problem. Okay, anyone else is not given what you should have gotten? Okay, so this is simple interest. Simple interest is some arithmetic, right? Addition, subtraction, sometimes depending on what we're doing, and multiplication. Simple interest is pretty clean. Compound interest is a little less clean. So compound interest is interest that compounds more often. So some examples are annually, semi-annually, monthly. We'll come back up to those in a minute. And the formula for future value in this case looks like the following. It's P times 1 plus R over N, and now it has an exponent of NT. Now part of that looks like the other formula. The P at the beginning, the parenthesis, the 1, those pieces are the same. But there's a division piece that we didn't have before, and there's an exponent piece that we did not have before, and there's a variable, n, that we did not have before as well. Now most of the variables we've had, and they're the same. A is the amount after 2 years. P is the principal, which is the amount that you're borrowing or you're investing. R is your interest rate as a decimal. T is your time in years. So the new one is n. N is the number of compoundings per year. That is determined by the language on how it's compounding. So here's 3 of them above. Annually would mean that it would happen 1 time per year. Annual. Annual means year, right? What do you suppose semi-annually means? Yeah. So semi is a prefix of SEMI, right, of 2. This is actually 2 times a year. What it literally means is every 6 months. Right? It's like, think semi-annual sale, right? They mean twice a year sale. So this is n equal to 2. What would n be if it's monthly?
12.
That'd be 12. Okay, let's run through a few others that you might see, just so that if you do see them, we've mentioned them. What do you suppose quarterly would mean?
4.
Yep, 4 quarters in a dollar, 4 quarters in a year. So quarterly means n equal to 4. What if it said weekly?
7.
Careful, we want to talk weekly, we mean like how many weeks are in a year.
Oh.
How many weeks are in a year?
Or in a year?
Yeah, weeks in a year. 52. Somebody's got it, 52. There are 52 weeks in a year. It's a good thing I asked. Now we know, 52 weeks in a year. Maybe I should ask you, let's do this one just for fun. What about daily?
All right, that's too much.
Ooh, 365. There's 365 days in a year. We are going to ignore leap year on these discussions because the calculation's close enough, it doesn't change. So, all right, let's do one more. One more that's a little less common, and in its phraseology anyway. Bi-weekly. So, do you guys know what bi-weekly means?
14?
Nope. It's every 2 weeks. Bi-weekly means every 2 weeks. So if there's 52 weeks in a year,
26.
it'd be 26. So I mention this in part because some of you probably get paid bi-weekly. My children do. 2 of my children work at McDonald's, and one of them works for Aramark at a nursing home. They all get paid bi-weekly. In fact, one of them got paid today, and one of them is getting paid tomorrow. Either 2 tomorrow, okay? Every 2 weeks they get paid, so they get paid 26 times in a year, okay? All right, so we're going to keep those in mind as we move forward to our problem for compound interest. Ready?
Wait, I'm not done.
Okay. Okay, so my math lab likes to put some of these in here kind of like a chart like this, and they're filling in the chart. So they give us some information. They ask us to find the final amount or future value that's equivalent to them asking us to find A.
Dr. Hintz,
Yes.
I don't think I got the bottom future value for compound interest on the last slide. I did not. I
Okay.
will take a picture of it.
Sounds good. Got it?
Thank you.
No problem. All right, so in the chart is all the details that we need for that formula. So let me just write the formula on the screen first. The formula we're looking at is equals P times 1 plus R over N to the NT. That's our formula. So looking at the details above, what is the 7,500 in terms of these letters? That's P. Okay, so it exactly is. It's just 3,500 or 7,500. What is the 3.5%?
The top of the fraction.
0.035.
Okay, so it's the rate, and we have to turn it into a decimal. So if I were to express 3.5% in its actual percent decimal form, it would look like 3.5%. Everybody good so far? But if I want to turn the percent into an actual decimal, then I need to move the decimal place 2 to the left, which means it's 0.035. Okay, is that okay for everyone? Again, that's one of our places that people tend to make mistakes if mistakes are made, is with the percentage changing to a decimal. What is semi-annually telling us?
Twice a year.
Yeah, it's telling us twice a year, so the N is 2. And then the time being 25 years tells us that T is 25, right? Okay, everybody good?
Yes.
Okay, so we're going to put those into their correct locations in this formula. So I've got 7,500 first. I have 1 plus. I've got the 0.035 on top. 2, on bottom. And then I have 2 and 25 multiplied in the exponent. Okay, now hold tight real quick before you put in the calculator. Okay, does everybody have this written down? Okay, my number one suggestion to avoid your calculator accidentally messing up without you realizing it is this. Multiply the exponent pieces together before you put it in. Okay? There are several ways in which your calculator can interpret this series of parentheses and so forth, and one of them is to do it wrong. Okay? Our easiest way to avoid that is to multiply the exponent pieces together, and in this case, that would give us a number 50. Is that right? Okay, so in your calculator, here's what you're going to put. You can actually put all the parentheses and everything that are here. You're going to put in 7,500. You're going to put a parenthesis. You're going to do a 1 plus. You're going to do 0.035, and then you're going to hit the button that says division, which will then turn it into a fraction, in most cases anyway, and a 2. You're going to hit the button that looks like an arrow pointing upward or a caret, which will push an exponent up for you, and you will put in a 50.
Is it okay if we did the fraction?
It will look like a fraction in most, and depending on your version of your calculator. So if you put the division button, it will turn it into a fraction.
Gotcha.
Yes. So when it's done, it will still look like this version with a 50 in the place of the 2 and the 25, but I'm trying to show you the keystrokes. Does that make sense?
Yes.
Okay, so one of the comments that I've gotten in evaluations before is that students feel like that the review day is not enough practice with the calculator. That's why I'm making you do it in class today and
Are we supposed to
Tuesday.
get a decimal?
You're supposed to get a dollar amount that should be more than 7,500.
Yes.
And it will have lots of decimals though, Kaylee, yeah.
Here.
Okay, so somebody tell me what you have rounded to 2 decimal places because we're working money, okay?
17,855.
Okay. Did everybody get 17,855.92? Fabulous. So I'm going to zoom in a second. That's going to go in our final amount column. So this is 17,855.92. Now, the last part of this, that final blank, is asking for the amount of the interest. Notice, there's no formula for I equals here, correct? And it's not telling you to come back over here because it's not simple interest. It's still compound interest. So think with me for a moment. If I started with 7,500 and I ended with 17,855.92, how can I find how much interest I had?
10,305.
Okay, so you're giving me an answer. Can you give me a description of the how?
Well, you started with the 7,500. The interest was accrued over the
I think you're overemphasizing my question. My question is simply, what operation did you do? How did you get the 10,000? What did you do?
I just subtracted.
There you go. Okay, you subtract, right? You take your final amount and you subtract off the amount that you invested, the principal. So our final amount was $17,855.92. We subtract off the $7,500 we started with, and we end up with 355.92. Is that right? Yes? Excellent. And that would go in this top box here. 10,355.92.
Is that like realistic for an amount of interest that could be accrued?
So the better question really is the interest rate and the amount of years and all of that possible?
Yeah.
So yes, a 3.5% interest rate is not actually crazy. Far more likely 3.5% would look more like a mortgage interest than maybe a savings account interest. However, my kids do have high yield savings accounts that do actually hit 4%. So it kind of depends. I mean, they're clearly not leaving it there for 25 years. The other thing that makes it a little bit unrealistic is that most of the time when we have like a savings account, you put money in, you take money out. You put money in, you take money out, right? This says you're putting it in and you're not touching it for 25 years. So yeah, could this happen? Sure it could, but it probably would not have quite the same details in there that would make that happen in the end. Okay? All right, any questions on that one? Okay. The next question asks us for something called present value. Whoops. Present value is another way of describing principal. Okay? Present value is another way of describing principal. So in terms of our formula, because it says compound, right, in it, the formula is still the compound interest formula. But it's asking us to find P this time, not A. Now we're going to do the calculation and then I'll explain what it is we've found after we do it, okay? But the calculation simply says the P is what I don't know, and in order to solve it, I must be given everything else. So it says future amount, that's this amount right here. So the 9860 is going to be in for A. I have 1 plus. What is my R value in this problem?
0.08.
Yep, 0.08. What is N? 4, because it's quarterly. And there's a 4 in the exponent as well. Time T is 10. Okay, what is the first suggestion I have?
Multiply that exponent.
Yep. I would not leave this as 4 times 10. I would rewrite it and think about it as the number 40. Now here's what you do. You're going to take your calculator and you're going to put in everything over here. This is going to require a couple of steps. You're not going to just be able to plug it all in from the get-go the way it currently looks on the screen, okay? You're just going to do the right-hand side. So you're going to put in parenthesis 1 plus 0.08. You're going to hit the division button, which will turn it into a fraction. You're going to hit the caret button, which will turn it into an exponent to the 40. This is the data that you're going to actually enter. It will look like the version above it. And as you write it down, the answer, I want us to write it down with several decimal places. I'm going to say 6. 6 is overkill. 2 is not enough. I'd rather overkill because then I don't have to rounding errors showing up. So let's write the answer down that your calculator gives you with 6 decimal places. You don't have to worry about the rounding of the last one. Just 6 of them written down will be sufficient. So what number does your calculator give you with 6 decimal places on this?
2.208039.
Fabulous.
Or, oh, yeah, you can't.
Yeah, you could take the 39 and write it as 40 if you want, but 39 will be just fine. Okay, is that okay with everybody? Did your calculator give you that? Now's the time to say it if it didn't. Everybody's calculator gave it that number? Excellent. How am I going to solve for P?
You can divide your A.
Yeah, you're going to divide the A, the 9860 by the 2.208039. Now, when you do this, you do need to round now to 2 decimal places because now we're actually giving the answer. The answer is a rounded version in terms of money. I'm going to suggest for the most part of what we do today, we're just going to round to 2 decimal places because we have money to 2 decimals. But MyMathLab could tell you round to a whole number, so just pay attention. What amount of money is this giving you at the end?
$4,465.
Excellent. $4,465.50. Okay, so do you remember back at the beginning, the leading idea, it talked about how small investments now and what that value is in the future, some kind of phrasing like that. Does that sound familiar? Talked about that? This is actually a really good example of that phraseology. The amount that we found at the end, $4,465.50, is the present amount that I would have to put into an account that has 8% compounded quarterly and leaving it there for 10 years in order for it to accumulate to $9,860 at the end of that time. That's what this is. This is the present value of the future value amount, $9,860. Okay, that's what we found. Okay, any questions on that one? Present value, principal, P, all go together. Okay, our next one is effective annual yield. This is, I think, the last place I'm going to have you actually write things down. And then we'll take some pictures after this. This is the annual interest rate that you receive or pay, taking compounding into account. It's otherwise known as the APY. You may have heard of APY before. APR and APY usually come up when people talk about car loans, sometimes credit cards. You'll hear those phrases. The formula is written as Y equals, and then in brackets we have 1 plus R over N to the N. We subtract the 1, and we multiply by 100. This piece right here is straight out of our compound interest formula. You see that piece matching up? Yes, sir.
So are we multiplying by 100 or are we like multiplying it by itself?
Yeah, we're multiplying by 100, and then this right here, percent, is the unit at the end. We have a percentage when we're done with the problem. So we're not actually, like, there may be, I didn't go and actually look, there may be a button that says percent in your calculator. Some calculators do have that. You're not hitting a percent button. That's not the point, okay? But percent is the unit at the end. Kind of like a dollar amount would be a unit at the beginning of a problem. Percent is the unit. So what does this do for us? Well, what effective annual yield or annual percentage yield, APY, does is it allows us to compare rates. So if you have one rate at some, say 3.5, and you have another rate at 3.25, but one of them is compounding quarterly and the other one's compounding daily, it's very difficult to compare them because two different variables are different. They're different in their percentage and they're different in their compounding. Does that make sense? So how do you know which one's better? Because you can't just say, well, it's better because it's a higher percentage if it's a lower number of compoundings. They counteract each other. So how do we decide? Well, we can decide by finding both of their APY. And that comparison actually will tell us by using that, comparing apples to apples. Like we're actually able to say, okay, given all the other things that are different, now I can make a decision because I've found the APY for both of them. Okay, so finding the APY is our next problem. Come on. All right, we have a bank account. It gives us a nominal rate, So one of the things I like to show you in this lesson, I guess, if you will, is words that mean the same thing, right? Nominal rate is also known as just rate. It's the R that's in our problem. And it's also what is also called the APR, or the annual percentage rate. All those mean the same thing. Okay, so nominal rate is the normal rate R. APY is the effective rate instead of the nominal rate. Okay, just different words for the same thing. It tells us that we have 2% on savings deposit, and it wants us to find the effective annual yield. That's what we called Y on the previous screen, also known as the APY. And it tells us that it's compounded monthly. So that formula on the previous screen looked like this. And the good news is there's only two things that we don't know in this problem, R and N, right? There's only two variables. And we're given both of them in the problem. So we've got a bracket, a parenthesis, a 1. What value do I put in for R?
0.02.
Yep. So I usually leave off that leading 0 and just put 0.02. If you want to put a 0 in front of the decimal as well, you certainly can. What is our value for N? 12. Now I have an exponent of 12. I subtract my 1, and then I multiply by 100. Two options here. One option is you could just enter this right here into your calculator and press enter, and then hit times 100. That is probably what I would do. Option number 2, if you enter in your calculator, is you start with 2 parentheses, because the bracket can be written as a parenthesis as well. Then you put in your 1 plus, you have your 0.02, your division by 12, your caret to the 12, minus your 1, and then, hang on, times your 100.
Where's the brackets at on the one?
So that's what I was saying is that I wouldn't look for brackets. We're just going to replace the brackets with parentheses. Yeah, they're just different grouping symbols that are a little friendlier when we have multiples of them. Calculators tend to just use parentheses only. They don't have to, but they tend to. So if I were doing it again, what I would do is I actually wouldn't worry about the brackets. I would just do the part that's there in yellow. I would press enter, and then I'd times 100. But you'll get the same answer if you do it either way. Okay, so on the fly, I keep telling you how many decimals. My math lab's going to kind of do the same thing. They're going to say, report this to so many decimals. I'm going to have us report this to 3 decimals at the moment. Okay? So the answer has to be very close to the 2 it started with. If you're getting something significantly larger, you've made an error. And if you're getting anything smaller than 2, you also made an error.
I got like -98.
Yeah, negative's not good. If we got a negative, we've got an error, probably in a sign or maybe in a decimal place. So double check those, Kaylee. Did anybody get an answer that's close to 2 and slightly larger?
2.0.
Okay. 2.018 is what you should get, percent as the units.
I don't see what I did wrong.
Okay, let me come look at it. Do you see this times 100? Multiply the 1 and close the parentheses.
Oh,
That's why I don't like the parentheses. Too many parentheses.
Cool. okay.
Anybody else over here not get a 2.018?
I did.
Got it?
I just misread it.
All is good?
Yep.
Okay, this is why we're practicing with calculators, because I don't want the errors to happen on the test, because that's a far more detrimental environment, right?
That's right.
Yeah, that's not good. Okay, everybody good?
It's not 2.
Okay, very good. Okay, so again, it should be close to 2, which it is, slightly more than 2, which it is. At the very least, this is a reasonable answer. True? Yeah, and it is the correct one for this as well. Okay, now I'm gonna have you take a picture. You ready for a phone out? Grab your phone. I want you to take a picture. There's gonna be a couple pictures in this section. Here's our first one. Continuously compounded interest. So snap a picture while I discuss what this is. This is interest that is compounded at a continuous, as opposed to monthly or annually, etc. rate. The formula for it below is A equals PE to the RT. This lowercase e really is a lowercase e, and it's in your calculator. Now, depending on what version calculator you're looking at, it might be in a slightly different place. If you're using mine, I can tell you where it is. So on the top left corner of the calculator, you've got a green button that says second. Do you see it? Okay. And 2 buttons down from that, you have a button that says LN. Do you see it? Right above the button that says LN, written in green, you should see an E to the X. It looks like this. Okay, does yours show that? Do you see that button? Okay, so the way you get to that button is you hit the green button and then you hit the LN button. Okay, so practice that first. Just hit the green button, hit the LN button. Did it show up with E and a little dotted like box up here in the corner for an exponent? Perfect. Okay, so clear that out and we're gonna put an answer in a second here. E is the number, right? E is actually approximately 2.718. That's not exact. E is irrational, like pi. Pi is 3.14, approximately, yes. But if you remember learning about pi in geometry or a course before that, it never repeats, it never ends, it goes on forever, all that kind of language. E does the same thing, okay? Now, continuously compound interest has an application, but it's not the application that's being described here. You cannot go out and find a bank account that's going to give you continuously compounded interest. That's not the application, okay? This is how it would work if it were, but that's not the application. So we'll get to the application in a moment. All the other letters are the same. A is the amount after 2 years, P is the principal, R is the rate as a decimal, and T is the time in years. All the rest of it's the same. Okay, so we're going to take a look at the same problem number 2 that we did before. So flip back if you would like. In that problem, we had our principal that was $7,500. We had our interest rate that was 3.5%, turning it into a decimal is 0.035. We had an N, which was how many times it was compounded, but that doesn't apply in this problem, so I don't need that piece. And we had a time that was 25 years. Okay, does everybody see that chart back on problem 2 with those details? I've just rewritten the pieces that matter here, okay? So our formula is A equal P, E to the RT. P principal 7,500. E is the button in the calculator we're going to use in a moment. Our R value, 0.035, is part of our exponent, as is the 25, like so. What's the first thing I'm going to suggest that you do?
Multiply the exponents.
Yep, multiply the exponents. And this one you might want to actually use your calculator because they're not nice whole numbers. What is 0.035 times 25?
0.875.
0.875. Okay, is that okay for everyone? So in your calculator, I would hit 7,500. I would hit the second button and then the LN button, which will pull up the E. It'll have a little exponent location for you to put in 0.875. Now the answer we get is still going to be pretty close to the answer we got on number 2, but it should be a little more because continuously compounded interest happens more frequently than semi-annual interest, which I think that was the one we had before. Yes.
The answer?
Sure. What'd you get, Kaylee?
17,991 and 56.
Fantastic. Do we have a second on that?
Mm-hmm.
That look good?
Yep.
Okay, so is it close to the same answer as before? 17,000, that part's great. I mean, yeah, that's pretty close. Is it slightly more?
Yeah.
Yes, so at the very least, it's a reasonable answer and it is the correct one. Okay, but like I said, you're not going to go find an account that gives you continuously compounded interest, so what's the application? Okay, grab your phone, take a picture. The application is in terms of something called inflation. So inflation is the increase in cost of living over time. That is the purchasing power of your money over time, CPI, Consumer Price Index. is it's published by the U.S. Bureau of Labor Statistics, and it reflects the prices of items purchased by large numbers of people. So think bread and milk and peanut butter and ground beef and the value meal at McDonald's and the gas at the gas pump. All the things that people generally buy on a fairly regular basis, okay? It's a huge list of things, and they figure out percentage-wise what that's gone up over time. So you can figure out what the cost of inflation is on a given time period, usually. You can look at it for your car prices. You can look at it for your cost of your education, right? Like cost of tuition at a university, things like that. Continuously compounded interest formula can be used to find newer prices due to inflation. All right, that's what this is actually used for. So here's the way this works, an example anyway. In 2010, a small car costs about $18,500. This is an average cost. We're going to find the inflation price for the 2020 car. That's a small car price. This is not the same car, right? I'm not buying the same car in 2020 that I bought in 2010. I'm buying the same type of car, right? So like when I think about like the car that I bought when I was 16 and the kind of like what it was like, it's the same kind of car that my kids bought when they turned 16, right? It's not the same car, same kind of car. That's what we're comparing. All right, so inflation works this way. So we have our continuously compounded interest formula, A equal P e to the RT. What we're looking for is the amount in the future. A is always in the future, okay? And P is in the present or past, depending on our perspective. The original. So the original car we're looking at was the $18,500. E is the E in the calculator, right? The 2.718-ish. What is R in this problem?
0.05.
Okay, so it's the 0.05 or 0.05. What is my time? 10. So in the scenario we're looking at, it's the time frame between the 2 years, right? The 2010 car, the 2020 car, it's 10-year time frame. And what are you going to do first?
Multiply the exponents.
Yeah, and if you multiply these exponents, you're actually going to get 0.5. So in your calculator, you're going to type in 18,500. You're going to hit the second button and the ln button, which will pull up the E, and your exponent will be the 0.5.
You get 30,501 and 34 cents.
So the approximate car price in 2010 was 18,500 compared to the equitable car that you could purchase in 2020, which was 30,501. Okay. On a smaller note, since I mentioned the value menu at McDonald's, this is very similar. Okay. So eons ago, you guys don't think I'm this old, but eons ago, McDonald's value meal prices were about $4. Do you know what the minimum wage was when I was at that age? About $4. Okay. So do you know what the value meal costs are at McDonald's about right now? About $9, give or take, 8 or 9. Yeah. That's not what I'm talking about. I'm talking about your regular old like number one or whatever. Okay. Do you know what the minimum wage prices are right now? About $8, $9. And I'll tell you, even though it's not minimum wage, nobody's paying minimum wage except if you work at OBU. Sorry. Yeah. My kids make $10 an hour at McDonald's right now. Yes, they do. Yeah, they do well.